People could take their seats. Plenty of room at this end. There's plenty of seats at this side of the room. Excellent, good. Good, welcome to the second breakfast seminar of the year, and it's my pleasure to welcome and introduce Dan Winson. First, I'd like to begin by paying my respects to the traditional custodians of the land on which we're gathered today, the Gadigal people of the Eora Nation, and pay my respects to their elders, past, present, and emerging. Today's speaker, Dan Wilton, is the CEO of Wagga-based connectivity company Zetifi. Zetifi actually came to our notice quite a while ago now when we were doing our first physical sciences fund, and it was one of the first recipients, and indeed it's become one of the poster childs for the program, and we've had a lot of successful companies now go through it, and shows really what the program's all about. It's about taking technology which genuinely needs a bit of an oomph into something that's genuinely commercial, that will result in a useful and valuable technology company. And added to this, to really support not just technology in the Sydney Basin, but across the entire state. And I think this is a great outcome for the program. We're going to hear from Dan all about this. Zetifi have also been successful. They actually got a second round of PSF for a different type of product, and they've also been involved in our small business innovation and research program, which is where government themselves put up challenges and ask companies to try and solve them with new technology. So it's great to see Dan contributing to so many of those things. And of course, additionally, they've gone out and raised quite a lot of private capital, which is really the whole aim of what physical sciences and building a company is all about. And also now you're selling lots of gear, which I think is the most important thing. So today, Dan will share some of his real-world insights from Zetifi's award-winning R&D and showcase how this technology can drive growth, efficiency, and inclusivity in ever-evolving digital landscape, particularly in the regions. He will also look at how that space looks like more generally, how connectivity developments in Wi-Fi, 5G, RedCap, 6G, Wi-Fi, HaLow, direct-to-cell and LEO satellites, lots of acronyms there are in this space, I'll tell you now, and really describe the essential role that Zetifi's technology plays in this landscape. So please join me and welcome Dan Winson to speak today. Thank you very much.
Thanks, Hugh, and thank you, everyone. My name's Dan Winson. I am the founder and CEO of Zetifi. We're a company based in Wagga Wagga, New South Wales. Very proud to be the leader of a regional-based manufacturing company and very appreciative of all the support we've had from the New South Wales government, as well as the Commonwealth in getting to the point we are now. So 25 years ago, I was studying IT at university at Charles Sturt in Wagga Wagga. And my favourite subject was ITC 242, which was data communications. So I was very happy when I was asked to come and speak today, because what we're talking about is a general overview of the data communication space. Some of the acronyms have changed a bit. When I was studying wireless sensor networks, we were talking about Zigbee and other things like that. But the technologies might have changed, but the general goal hasn't really changed a lot. Not really at all, in fact. The opportunities have increased. And we've really got a huge opportunity in front of us in the coming years with the emergence of new technologies like LEOsat, like RedCap 5G, the emergence of BLE as a leading technology. We're going to give a nice snapshot overview of some of these different technologies. Just so that you can have a little comfort in my capabilities to deliver this, just a teensy bit of backstory about myself and Zetifi. So 25 years ago, studying ITC 242, real interest in data comms, and decided that I would be a network engineer, and then wasn't really that interested in business, was mostly in the technology piece. but was having a beer at a friend's place in Wagga, a local rugby coach named Richard Skellen, and his brother was there. Is David in the room? David was going to come along today. He's not here yet. He's running late. Anyway, I got to meet my friend Richard's brother, David Skellen, who had just sold his company, Radiata, or he and Neil Westie's company, Radiata, to Cisco. And David told me the story of that. And yeah, that sparked my interest in entrepreneurship and the idea of changing to a not just straight technical track, but actually doing a startup was sort of birthed from that. I started my own electronics business in Wagga Wagga and learned very quickly that being a commodity was not the best path to success. JB Hi-Fi kind of displaced the need for my little business. I went back to university, did a master's degree in wireless networking, took on a role of teaching network engineering, so Cisco and Ubiquity and those sorts of products at TAFE New South Wales. Probably 20 years too early, to be honest, to be a teacher. Loved it, but was just not the right stage in my career for it. So when I was given the opportunity again by the New South Wales government to go and do a scholarship to San Francisco and study startups, that was it. I was like, okay, I've got to leave teaching, do a startup. I don't want to leave Wagga, so ag tech was the logical choice. I started Zetifi, which was formed with the idea of providing better connectivity for farmers. And then, it has evolved over the years, over the last 7 years. Our first investor in that company was also Dave Skellen, in fact. But we've as a company evolved from providing just connectivity to farms to building smart antennas that act as an integration point for vehicles, for hotspots, for other devices that need better antennas, but importantly, also need a gateway to provide connectivity across a lot of the technologies we're going to be talking about today. So we work with companies like Morse Micro, who are the experts in HaLow. We work with companies like ICOM, who are the experts in LMR. We, of course, work very closely with Starlink. Can't really avoid them in this market. They are a very important player, and we work very closely with them. We're doing some pilots right now to provide connectivity in disaster-impacted areas using Starlink. And we work with Telstra. So full disclosure, Telstra led our Series A 2 years ago. We raised $12 million, and Telstra was our biggest backer in that. And we're working with them as well across a whole range of LTE technologies and IoT technologies. So hopefully, I'm certainly not an expert in all the technologies we're going to be talking about today, but I do have a pretty good overview of a lot of these, and looking forward to, at the end of this talk, we will have 15 minutes set aside to do a Q&A if I manage to run on time, and it has been a while since I've had to talk for this long, so we'll see how I go with that. Quick note, during the session, to try and keep this interesting, I've got some polls set up. So we will have 10 different questions looking into the future and hoping that each of you can use your phone to scan the QR code when it comes up. They're very simple polls, as far as very simple to respond to, but incredibly difficult to actually forecast accurately. This is a little bit just more of an opinion poll about whether you think that the facts that we put up there are going to be true or not, and your views on that. So get involved, and we can explore some of those ideas at the end of the session. So yes, long list of technologies. We will start with cellular because it is pervasive. It is the one that all of us... Is there anyone here that doesn't have a mobile phone? It's just an interesting question. One. Okay, there we go. Maybe two. If you asked that question even 10 years ago, the response would have been entirely different. It's very easy to forget just how quickly this has emerged as a pervasive technology. We're up to the 5th generation of networks now. Around 50% of handsets are going to be able to connect to 5G within the next year or two, and the networks are growing at a huge speed. That said, as an independent view and not aligned with my thanks for Telstra's investment, I would say that 5G as a technology has largely failed. The reason I say that is that it failed from a startup founder's point of view. It didn't have a job to be done. It was put out there as an amazing technology, as a solution really looking for a problem. We were all sold the idea that 5G was going to be amazing, it's going to be super fast, low latency, all these things, and they are true, but the killer application for that has not yet emerged. So it works, it does what it's meant to do, but why did we do it is a pretty viable question, I guess. It is possibly starting to recover. You can see the shift in the industry where they were all talking about speeds, and they still talk about speeds far too much for my liking. Again, as a startup founder, it's drilled into us, and if you don't learn this, then you fail very quickly. What is the job to be done? Like people don't buy drill bits, they need a hole, so they buy a drill bit for the hole sort of thing. That sort of analogy fits this. 5G, they're putting out a new narrative. When I say they, I mean the industry, the people who sell these towers, the people who build out the networks and try and win your money. They're saying that the industrial applications for this, the security, the private networks are going to change everything. It's yet to be seen, keeping an open mind about it, but it is growing because, there is still a lot of value to be realised from this. The fixed wireless aspects of it, so using 5G. Another quick just show of hands poll. Does anyone exclusively use 5G or 4G in their household for their internet access rather than NBN, Starlink or anything else? So, yeah, we've probably got about 5% of people. So yeah, it hasn't dominated. That was another use case that people were expecting to really take off, and it's not that it hasn't worked, it just hasn't worked as well as we thought. Of course, the 3G network has just been shut down across major operators over the last 12 months or so. As a rural company, we are on the front lines hearing about concerns around that. The coverage has changed a little bit, is the word on the street, but the impact hasn't actually been that significant for the vast majority of the population. Most people can connect to 4G. 5G is working. Another quick question for the audience. Who turns off 5G on their phone to conserve battery life here? You're engineers, mostly, technical people? Yeah, I do as well. In the city, I do. In Wagga, I can run it okay because I'm not blocked by lots of concrete stopping the 5G from working. But when I'm in the city, my battery life's terrible if I leave 5G on. Sorry, Vicky. Anyway, they can fix that. 6G. 6G is coming, but it's 5 years away. So the meetings are being held now. And over the next year or two, we will see them agree on what it should look like. And over the coming years, they will ratify standards. And then within 4 or 5 years, we'll see the first deployments of that in the real world. So it's coming, but it's probably a bit more of a measured deployment than what we saw in the transition from 4G to 5G, or more importantly, probably the shutdown of 4G is not on the horizon. Like, we don't need to stress over that in the way that we did have to stress about 3G shutting down and having a lot of devices that weren't going to be supported. Another interesting one about this whole space is the emergence of APIs. So I'm taking a lot of these notes from what was spoken about at the Mobile World Congress this year. And it seemed that a lot of talks were talking about APIs, so interfaces between different sets of information and different systems. So there's a standard called Camara, which is being led by the Linux Foundation. That standard is allowing telcos like Telstra and Optus and AT&T, Verizon, those guys, to expose information through their network to the public and to other system providers. So things like location information, fraud detection, being able to request higher priority services across that cellular network for a fee, I presume. All of that is emerging and is expected to be a big revenue opportunity for the telcos, which is why they're interested in it, but also an interesting space for startups like us because there's innovation opportunities there. Last point, as far as an update goes on the cellular space, well, last point on this slide, and then we'll talk about some other stuff. Energy efficiency is increasingly important. So around these towers use a lot of energy, and both as an ESG goal for these carriers, but also just as a cost-saving measure, which of course, when those two work hand in hand, is when we see real change happening. They think they can save 60 or 70% of that network cost. So overnight, when the network load drops dramatically, they can turn it down, which makes a lot of sense. So that's another sort of key thread we're expecting to see in the next few years. A little later in the talk, we're going to talk about AI and its impact on networks, including cellular networks, and we'll also talk separately about direct-to-satellite non-terrestrial networks, so when your phone is going to be able to talk directly to the satellites. That's quite interesting as well. But the largest area of growth is expected to be this is a ridiculously large CAGR number, 62%, from 1.2 billion to 21 billion across the next 5 years, private networks. Now, the key driver for this that everyone's saying, and I'm not backing this number, by the way, these research reports that are out there, there's a lot of variability in it, and it's interesting. They want to charge you $5,000 for the full report. They give you the top line numbers. We don't have the sort of money to buy the full report to understand their full justifications, but the fact that there's 4 or 5 different reports, each with different numbers in there, and each wanting to charge us $5,000, it's an interesting one. But it's a good one to speculate on, and it's good to accept that reality that it's very hard to forecast 5 years in time. But yeah, between 20 and 40% is a pretty common estimate there. The top end of that estimate was from AWS. AWS obviously stand to benefit if there are more deployments of private networks, because their cloud infrastructure can host a lot of this stuff that used to be on towers, which gets the tower cost down, and then you can put everything in the cloud. I've been told it's a mixed audience. I'm just going to define cloud because we talk about it a little bit, but just as a really simple definition of cloud. When we say cloud, all we're talking about is hosting your software on someone else's computers, probably in a data center. It's AWS have data centers all around the world, including in Sydney. They have racks and racks of servers, and you can buy the right to store some of your information and process it within their data center. They add a bit of value on top of that, of course, which is why our bill's so large from Amazon, but it's still worth it. They manage to price things just at that point where you analyze it and go, is it worth bringing this in-house? And you're like, no, it's not. We'll just keep paying them. But this growth rate, I think, if you consider it credible, it's probably credible because it is coming from a very low base. So it is possible that it could hit this number, but it's also equally possible. And interestingly, if you look at the announcements made at Mobile World Congress this year, as it gets closer to the period where people are being held accountable for their forecasts, they're backing them off a bit, that it will take a little bit longer and may not be the massive level of growth that people were originally saying. So our first poll, let's see what you think. Let's see if you can scan this code. I've got the code up on screen there. And if I do this right, I will manage to make sure this poll is actually active. Sorry, I don't have a view of that. I just want to make sure I got the right poll up there. Yes. Let's see. We'll give you about 20 seconds to do it, and while you're doing that, I'll keep rambling about why each answer may or may not be correct. And of course, there are no correct answers yet. It's just in 5 years' time we can figure out whether you were right or not. So the economic drivers for going private are largely around reliability. So on a mine site, if you're using Wi-Fi and that Wi-Fi system isn't sufficiently reliable to run your autonomous trucks, then your cost per hour easily justifies the deployment of a cellular network that's private. Some of the other drivers are security, because existing Wi-Fi standards are not as secure as cellular standards. Then we can get into the argument about whether Wi-Fi is adequately secure. And then there's the commercial side of it, like are the companies that are coming through as disruptors, the small cell manufacturers, the Amazons of the world that can take a lot of the information or the systems that you need to run a cellular network and run that as a service inside the cloud, who's going to succeed there? This is my first time using this software. I apologise. I'm trying to figure out how to get the answers from people. 1 second.
Someone said we can put our hands up.
Yeah, you could put your hands up. That's good. That's a good idea. There we go. There's my controls. Don't clear responses. Click responses. There we go. Success. What did you say? Okay, that was interesting. Yeah, I don't have any strong views on this one, but I would go with false on this, to be honest, because I think for mining companies, there's not enough mine sites to justify it. I think defence and public safety could possibly change this. So if the public safety mobile broadband network project gets off the ground for real, then that could impact this in Australia. But and globally, I could see it having an impact in some manufacturing scenarios. But we know that Telstra are spending $800 million over the next 4 years on their network. like that's just Telstra. And if you consider how much AT&T's, Verizon's, and the competition that's forcing them to continue to compete, investing in new technologies, I think we're going to probably see those providers leading the way as far as the most deployments. Okay, let me see if I can get back to the right spot. 1 second, percent from current slide. There we go. No, that one. There we go. Next topic. Okay, so Starlink. Many people come to me nervously when I'm talking about my company. They go, oh, so Starlink? And it's like, yeah. So our business started trying to provide connectivity, or actually providing connectivity for farms, and we did that very successfully at a pilot and project stage. But in order to launch solutions for the mass market, we had to transition to mass manufacturing. We purchased everything we needed to do our first production run of that, and then the Starlink Mini launched. And we're like, okay, tough spot. Do we proceed with this and go after it, or do we retract and decide to put our efforts and capital elsewhere? We decided to retract. Elon wins this one because he has rockets and we don't. And you'd be crazy as a startup to go head to head with a company that has that amount of capital behind them and has proven that their tech works. So Starlink's profit in 2022, when we raised at the end of 2022, we raised a $12 million Series A. Their profit was minus 128. Their loss was 128 million US. In 2023, Starlink's profit was $3.8 billion. And 2024, they doubled their revenue to 13 billion. It's working. So doesn't mean it's sustainable, doesn't mean that as it gets congested that it's going to be working forever. I'm not in any sense of the word an Elon fanboy, but as a realist and as someone who's responsible for steering Zetifi to success, have to look at the commercial realities of this, and they have got a product that works, that solves a genuine need. So they've kind of won the fixed wireless access market for now, at least. It's going to be interesting to see whether Jeff Bezos and others, so Project Kuiper, which is Amazon's competitor to Starlink, launched their first 27 satellites in 28th of April 2025 this year. So competitors are starting to come through. But I don't have Jeff Bezos' rockets either. Actually, they're not his rockets. So Jeff Bezos has got a space company, but Kuiper's rockets were actually launched on the United Launch Alliance, which is a joint venture between Lockheed and Boeing. So whether they can compete against Starlink, who have got very strong economics around their launch costs, will be interesting to see. But I still love Starlink because they launched this soon enough that I could actually make a decision and not go bankrupt. If we launched everything and tried to compete and then a year later they did it, we would be certainly struggling. And the flip side of all this is at any time when a market is disrupted, there's huge opportunities, especially for startups that can be agile and make the most of those opportunities. So for Zetifi, our key technology were the antennas on top of tractors that allowed you to switch your networks on the go, depending on which paddock you're in, like you go Optus or Telstra. Also change the radiation pattern of those antennas so that you could get better signal in more places. It turns out there are huge opportunities for us in building antennas in other sectors. So we'll talk about some of those sectors separately. So we're not going to head-to-head with Starlink, but some others are trying to, and we'll see how that goes. The other interesting one here is the speculation around just how fast this will grow. So right now, they've got a few thousand satellites up there. I should have that direct number here, I don't, sorry. But we're saying 27,000 by 2030. I think the exact number now is probably 5,000 or 6,000. 13,000, there you go, exponential growth. So 27,000 does look plausible. The magic number, it seems to be, is 60,000. So if they get to 60,000, there's a real risk that these satellites could sort of cascade into a explosive sort of situation where they start plummeting from the sky. Now, we don't know, this is a risky thing, and talking about risk, obviously, Elon is a risk in himself. He makes decisions, and you've got to admire the guy for that, but at the same time, as a nation and as an economy, we have to be like, okay, how much do we go all in on this? And you do look at what other nations are doing, and they're saying, well, we need a sovereign capability here, we need to launch our own satellites. Australia may not be big enough to do that. Like, we can do it in a limited way, but we're not going to be able to launch 27,000 satellites. So it's it's an interesting space. It is solving a real need. There are other relevant players in this space, so Viasat, HughesNet, Inmarsat, a lot of these older companies are having to pivot and find their relevance in the space. I don't know what's going to happen here, and neither does the stock market. You look at you look at what's happened over the last 5 years with the stocks in some of these legacy players, and you look at the stocks of what's happening with telcos, and they're still following the trends of the general market. I was expecting it not to. I was expecting like that Viasat stock would be more substantially impacted by Starlink's success than it has been. So it's interesting to watch. As far as next poll goes, let's see what you guys think. Now I have to. Will Starlink's early start? Like, we often talk about first mover advantage in the tech world. No, sorry, I have to. There we go. Go to the next screen. There we go. Will Starlink maintain their dominance? The reasons they could would be they have rockets, previously spoken about, like having your own rocket company helps. They have momentum and the first starter advantage.
You need to put the code up.
Okay. The code is up there, but we'll make it bigger. Thanks, Hugh. Again, just give people a few minutes to answer. Not a few minutes, a few seconds to answer. We don't have minutes. Won't lock it. Let's just see what people are thinking. Okay, pretty divided, understandably. It's a now, from the bleeding edge to what would seem to be a pretty stable and old school technology, really. Walkie-talkies. Who had a walkie-talkie as a kid? Yep. Who has one now? A UHF-CB radio. If I was in Wagga, that would be a lot more hands, but okay. So around 10% of vehicles in Australia have a CB radio. So CB stands for Citizens Band. We're a little unique in that sense. The ACMA gives us a chunk of spectrum, 477 megahertz, that lets us run up to 5 watts on a class license band to have voice communications and some limited data use on telemetry sort of applications. We're pretty lucky, I think. It's incredibly useful in Australia if you're traveling in rural areas, still widely used by caravanners, four-wheel drives, fleets, farmers, those sorts of people. It's relatively low tech, relatively inexpensive, but very reliable. It's the sort of thing that, you're not streaming images or high bitrate data over it or anything. You can send a location maybe, but that's about it, or a duress signal. Zetifi hasn't been active in this space until Starlink sort of killed the mobile broadband opportunity for us a little bit. And then we started looking at this space. We're also quite fortunate that we have team members that have worked in this space over the years. And because of that, we've been able to form some really strong alliances with companies that build radios that need antennas, need smart antennas. There's some interesting trends here as well, though, outside of Australia. So UHF-CB, Citizens Band, Australia-centric. LMR, which stands for Land Mobile Radio, is still global, and that's the one that's got a 9.2% forecast growth rate. I found that fascinating, and I digged into it to see, like, is this accurate? Like, it would appear to be so. You look at Motorola's stock price, Motorola Solutions, not Motorola, the company that used to make mobile phones. They kind of split that off and sold the phone part off to Google and their IP off to Google, and then Motorola Solutions, if you look at their stock price over the last sort of 10 years, it's, your perspective, going really, really well. That category, I think, is going to continue to grow really well. Basically, people don't trust yet the public carriers to carry this critical information as the only way to do it, at least in Australia. We have our government radio network, and we're talking about allowing IP connectivity over the, so IP, internet protocol connectivity over these public networks. So the public safety mobile broadband network would be the first version of that. That is based on a network in the US called FirstNet. So it's a really interesting, for a network engineer at least, and hopefully for this sort of audience, a really interesting solution to a pretty big problem. We've got limited spectrum. Private companies pay a lot for it. In the US, the way they solved it was that the government allocated, so the FCC allocated spectrum for public safety, and then the public safety FirstNet team allocated that spectrum or came up with an agreement with AT&T, who are the largest carrier, or the second largest carrier there, where AT&T could use that spectrum and run with it, put it on their network, but they had to give priority for use of that spectrum to the public safety mobile broadband users and for the FirstNet subscribers. So over there, the sheriff's departments, the firefighters, the ambulance, the first responder market get priority of that network, but AT&T get the benefit, the commercial benefit of being able to use that spectrum to increase their coverage. So we don't know what model it will take here in Australia. It's something that's been spoken about for around 10 years. And traction's sort of, like we've seen it start to take off and then nothing happened. But we're hopeful that we'll see something come out there, and there is a need for it, because if you look at what first responders use, it's not a walkie-talkie like we had as a kid anymore. It can be used for voice communications, but that's encrypted, and it's sent as a digital signal. And in addition to doing the voice communications, it can send a lot of over-the-top services, still limited bandwidth, but highly reliable, and it can be point-to-point, or it can be over the core, it can be off-hauled over Wi-Fi or over LTE. But it means that a first responder can have their location known. It means that they can send a duress signal. It means that they can identify themselves and track all of that extra information. So an interesting area that indirectly impacts all of us, because we've seen what happens when the comms towers go down during a natural disaster. So yeah, 80% of those outages are caused by power. So having independent infrastructure that can run at a lower power than the full cellular network, potentially making use of LeoSat, is a really promising emerging technology for our public safety professionals. Interesting one. All right, another poll. If we get sick of these, let me know. But you can just keep your phone out too. It will just refresh. If you've got it there on this page, it will refresh and work on whichever one we had. So you'll see it's still talking about Elon, and we'll skip across to this. So if the public safety mobile broadband network gets up, does that mean we're going to take down our towers for local radio? It's a lot cheaper if you just do it all through a central core, but it means if that central core fails, that you don't have the apocalypse scenario under control, or the satellites falling out of the sky scenario under control. So yeah, my thoughts on this one are a little bit stronger than they were in the past too. Yeah, and I'd agree with the people saying false there, that we need the resilience of terrestrial communications to account for any sort of disaster scenarios with satellites. And it means it's in control of each country, and I don't see politically that we would ever want to give that up. Okay. All right, I'm getting the hang of these tools now. We'll go a little faster. Wi-Fi. It's hard to believe that this technology is 25 years old. Invented here in Australia, commercialised the first chipset to have 802.11a, again, Dave Skellen, and Radiata team, so Neil Westy, who we work with now, on HaLow. So HaLow is an emerging Wi-Fi standard that I'll talk about in a second. What we've seen over the years with Wi-Fi is an increase in speed, increase in number of devices that we can have, increase in reliability, and reduction in latency over the last 25 years. So Wi-Fi 7 can do gigabits of data to multiple devices, and is a genuine opportunity to actually no longer have to run those blue cables through every building. Not all buildings possibly, but I think that we're approaching that same scenario of 5G here. What is the job to be done? Do you need 2 gigabits straight to your handset? So there's a lot of speculative concepts around what might be enabled by that, but I'm yet to see a killer application there. I ran an experiment when we were still trying to do the fixed wireless access market in Zetifi. I had a Telstra hotspot in my house connected, just via a Wi-Fi 5 access point, and I limited everyone in the house to 5 megabits. Didn't tell them, but I've got 3 kids, 13, 11, and 9, my wife, myself. There's around 35 devices in our house, so all the Sonos speakers, all the TVs, all the kids' switches, everything like that. So I'm not talking about 5 megabits across the house, I'm talking about 5 megabits per device. So it was still in total probably 50 megabits in available bandwidth, which is half of what you can get on any reasonable connection. 5 megabits, no one complained, not in the least. You can stream Netflix, you can watch YouTube, you can run a Teams meeting. If you've got a dedicated 5 megabits, you can do pretty much anything that anyone wants to do. So this obsession with speed tests is a little misplaced in my view, because it's really about what is the job that needs to be done and what do you need to do that. Rather than just throwing bulk speed at everything, having a network that's set up so that you've actually got quality of service where every device can have what it needs to do its job is, I think, probably more valuable. And that we'll see more effort and more investment put into that over time, and AI is going to enable a lot of that to happen. With that in mind, that's why Zetifi has partnered with Morse Micro. So Morse Micro, down the road in Surrey Hills, Sydney scale-up, I guess you don't want to call them a startup, because they've raised $200 million and are in, they're Australia's largest semiconductor manufacturer. Fabulous semiconductor manufacturer. So they designed the chips that go inside devices, including ours. We're working with them to implement Wi-Fi HaLow. So Wi-Fi HaLow runs at 900 megahertz. So it's a lower frequency to normal Wi-Fi. Normal Wi-Fi, traditional normal Wi-Fi was 2.4 gigahertz, then 5 gigahertz. Now we're looking at 6 and 6 gigahertz and beyond. When we're talking about megahertz, gigahertz, these spectrum things, basically megahertz is considered ultra high frequency, but whoever named that didn't know we were going to go so much higher. So it's a bit of a confusing fact, because it's actually kind of the lowest part of the spectrum that we're interested in, at least. It's suitable for voice only, but it'll go through trees really well. It goes a long way without having to pump too much power into it. As you get up to 2.4 gigahertz, over a few hundred meters, a tree, especially a wet tree or a tree that has a lot of water matter inside the leaves, is going to pull up that signal a lot. As you go up to 5 gigahertz, you've got trouble getting through walls. But the trade-off here is, as we go to the higher frequencies, we can go a lot faster. We can carry more information in those signals. Now, don't confuse that when we talk about 5 gigahertz with 5G. It's not the same thing, and we get a lot of customers confused with that a lot of the time. So 5G is a standard, and it does happen to use a lot of higher frequency signals. So mid-band for 5G is at 3.5 gigahertz. So it's not quite as bad as 5 gigahertz as far as attenuation or stopping that signal when it hits stuff. But it does still attenuate a fair bit, especially if you go to the high frequency, the higher frequencies, 26 gigahertz. Some of the 5G signals work at 26 gigahertz. I saw China recently announced that they've got 10G networks. And I was like, really? That's interesting that no one's actually ratified the 6G standard yet. But I think something had been lost in translation at some point there, because they were talking about using 10 gigahertz signals, not 10G networks. But yeah, back to Wi-Fi. Wi-Fi is doing the same thing that we've done with cellular. It's getting faster and faster and faster, but at the same time, there are some other emerging standards like HaLow that run at lower frequencies, which mean it's got better penetration, and that's a really exciting one for the Internet of Things. So we'll talk about IoT in a sec. But I want to know, if you were building a house today, it's probably a better way of framing this question. If you were building a house today, would you run data cables in it? Or if you were building an office, would you fit it out with data cables? So it's, or would you be more than happy just to have everything running off Wi-Fi? I'll make that bigger again. Sorry. So yeah, I renovated during COVID, and I ran Cat5 cables to all of the TV points, because as a wireless engineer and the owner of a wireless startup, I know wireless doesn't work very well a lot of the time. My first call with Dave Scallon, Dave's 5 gig Wi-Fi wasn't working very well in his basement on the call, which definitely helped me raise the money, I'm sure. Okay, let's have a look at, would you run cables or not? Or are you going to wait for the standards to improve? Mixture, okay. That's right. Looks like the cabling industry doesn't need to worry. There's still plenty of people out there that want it. In hindsight, I didn't need to run the cables in my place. I've got some of the Amazon Eero repeaters running, not because they're better or go further than Zetifi's repeaters. Ours go a lot further, but they're designed for outdoors. Theirs have got the switch that lets me stop the kids from using it after certain hours, which is really useful. Job to be done. That's a really good insight from their product management team. Okay. In researching for this talk, I was really happy to get a chance to look into Bluetooth in more detail. So Zetifi is doing a pilot with Telstra right now where we're putting our antennas onto UHF radios in their technicians' vehicles, and we're connecting those out to the cloud so that we can give the UHF radios in those vehicles information from a duress signal out through the radio to their Microsoft platform so they can get alerts to the right people when they need it, lone worker safety, that sort of stuff. But at the same time, we're implementing some little Bluetooth tracking tags to put on the first aid kits, so when the technicians roll out each morning, there can be a little alert saying on their Apple CarPlay screen, you forgot your first aid kit, or you forgot your duress alarm, or you forgot your gas sensor. Really simple stuff, but really valuable, and really our first foray into, well, second foray into Bluetooth. So we sell cellular boosters that improve Telstra network coverage. Those devices are called Selfis. They're the only legal booster you can get in Australia. They're a great device, but they often boost the wrong band. It's probably the biggest problem. If you're driving around, they just boost the first band they can find. We've set up our antenna, which knows where it is, to program the Selfi using Bluetooth to boost the right band based on where you are. So we started looking at Bluetooth as a technology, and we had to join the Bluetooth Special Interest Group, the SIG. It's costing us $20,000 a year, thereabouts, just to have one or two products certified for Bluetooth. But if you look at how much money they must be making across the industry, it's not enough to make anyone super wealthy, but it's enough to do a really good job of managing this standard. It turns out to be actually really helpful for a company because it keeps a lot of the dodgy people out of it. You've got to pay a little bit to be involved, but it means they can write reports like this. So anyone who's interested can, well, I've got one copy someone can have at the end, but you can download it yourself. I only printed it so I could read it on the plane. Yeah, market update that actually isn't just speculation, because we have to tell them what devices we're classifying, how many of them we're selling, all of those sorts of things. They audit all of this, and it means that we can trust some of the things they're telling us a little bit more. So interesting things like 3.5 billion Bluetooth PC accessories, so mice and keyboards, are going to be sold in 2024. Only 262 million Bluetooth-enabled speakers. Another really interesting one, this is a bit more speculative, but 2.5 million locations are forecast to have Auracast by 2030. So Auracast is a new implementation of Bluetooth audio. So like a lot of us obviously have the earbuds, that's one of the biggest categories. But being able to tap those into the location, if you're sitting here and struggling to hear me through these speakers, then you could pop in your AirPods if you had Auracast enabled here, which we'll talk to you whether we can maybe get someone to do that, because the Sydney Opera House was actually the first in the world to light up this technology. But they're forecasting that 2.5 million places will have it by 2030. So those solutions are emerging, as are some other really interesting ones. So shelf labels, they're saying that we're going to be moving to e-ink tags on shelf labels, which will be updated via Bluetooth Low Energy, ultra low power. And another interesting one, I don't think they've had a PSF grant, but there's another Wagga company that's building solar panels for indoor lights for those shelf tags, and they're based in Wagga Wagga, another startup. Yeah, 177 million smartwatches. Show of hands, which you can prove it very easily. Hold up your hand if you've got a smartwatch, if you're wearing one. Yeah, 177 million of those. I don't. I wear a Casio $30 watch to remind myself and my team about the whole jobs to be done thing, because like they all show me their new smartwatch each year that they buy, and it's like, how much was that? Oh, $500 or $1,000. That's nice. Hawken, our director, has got the top model iPhone one, but I was like, oh, how often do you have to charge it? And like, oh, this new model lasts 4 days. I'm like, cool, this one lasts 7 years. It's like, what? Yeah, I'm still amazed, and it also reminds me of the power of marketing, that we can be told that you need, like, I've had a smartwatch, and if you need it, you need it. Like when I was a teacher, it was awesome. But in my current role, don't need it. No job to be done for me. I love that I've got a 7-year battery life, and always on screen as well, which is not to be taken for granted. And it's thinner than any of the smartwatches, so interesting. All right, another prediction poll. This one is talking about whether Bluetooth is likely to really emerge in this category in the way that the Bluetooth industry thinks it will. So the Bluetooth organization has the highest growth rate around indoor location tracking. So we've all got very used to having GPS in our cars, on our phones, in our cars via our phones probably. I'll bring that code up if anyone needs it, but again, it should be following you along if you leave it on the page. So Bluetooth devices, I can buy them for about $5 US in small volumes. I'm sure they're cheaper than that if you go to high volume. That's a little tag that has a 3-year battery in it. So that tag contains a battery that would cost me more than $5 at JCar. And it comes with all the temperature sensor and the sticky tape on the back that I can chuck on something and track it. And that's buying 100 at a time. So I'm sure if we start buying in thousands, tens of thousands, or millions, that those prices will drop. These are like those air tags that you've got, but designed for commercial applications. So the first one we're testing with Telstra, is your first aid kit on board? If it's not, tell the technician. Those sorts of things. How am I tracking for time here, Bruce? 5 minutes, no worries. We'll have to go very quickly, but that's okay. Let's see what people think about this. Okay, people are very bullish on Bluetooth. So I'm going to skip that slide. No, I'm on the wrong page. 1 second. There we go. This one's interesting, mostly because it highlights that you can't trust everything you read unless you read a little more and then understand where they're coming from. So this prediction is actually a couple of years old. I couldn't find anything validating whether it's true or not. I liked it just because it's a stupidly large number and does a reasonably good job of explaining how big it is. This only works if you consider it as video. And you look at what percentage of that data is video, and it's like 99% of it. Doesn't mean that we're not going to have lots and lots of pervasive IoT devices, but the data that's being generated is almost all video data. I'm going to skip this prediction, sorry, just so that we can get through some more content. This one is very interesting. Direct-to-handset trials for LeoSat Cellular. For a couple of years, I was of the opinion that this wouldn't work probably, just because the information that existed in public was that the Doppler effect made it incredibly hard, that it had been tried for years and couldn't work. Then they got it working, and I changed my opinion. Strong beliefs, loosely held. Very impressive. They've sent 1 million text messages already in New Zealand in the first 4 months, and as that satellite network gets further populated, it'll be really interesting to see just how well it works. This isn't just Starlink. AST Space Mobile sent a text with Vodafone, TPG, over Easter. So this is coming. How well does it work? How clear does your view to the sky need to be for it to work? Yet to be seen. Commercially, what does it mean from a disruption point of view? What opportunity is there for Starlink, Apple, others to bypass the carriers entirely and have a subscription? So it's disruptive, there's no question there. Can't talk about technology these days without talking about AI, of course. Now, this is starting to be, like the impact of AI in networks and in technology is very keenly felt. So already the investments are coming through. So Telstra's spending, I think it's 600 million or 700 million. 700 million with Microsoft over the next 7 years, 100 million a year on AI. And that's a mixture of doing it for their service desk agents to get their costs down. It's a mixture of implementing it into their networks so that decisions will be made by agents rather than by analysts and network administrators. So it's growing scary fast, and I'm sure all of you are already seeing this in your jobs or in just in your lives, being able to use large language models to do things faster and to do things differently. But that next stage of that is seeing the enterprise impacts absolutely delivering real value. And if you don't jump on with it, then the risk of being left behind is also very real. I'm going to skip another poll, sorry. connected vehicles. This is another one that's been a little bit of a false start. We haven't seen self-driving cars really working in open road conditions. The political risk is so high, the safety risk is so high, but in controlled conditions we do see it. So we are expecting this to grow. I can now, current model Ford Everest, turn my car on and off, unlock it, all of those sorts of things are starting to come through. But are we going to see it actually drive itself? Don't know. It's not going to be technology that is the barrier, is my opinion here. It's more about, can we handle the safety aspect? In controlled conditions on mining and in agriculture, it's already working, it's already commercial. So we do have autonomy in some industries already, but will we see it happen? I guess the key thing is that connectivity will not be the barrier to it happening. It's going to have to be solving those safety issues. Anyone who's interested in the safety aspect and whether a Tesla should be allowed to self-drive, check out Mark Rober's video. He's a YouTuber that does a very good video showing whether you need LiDAR or not. Digital inclusion. Zetifi has been given significant funding over the years to improve connectivity in underserved areas. A lot of these problems have been solved with LeoSat as far as getting the connection down to a residence, but it's not getting it out in broadband everywhere that it's needed, and it's not providing the resilience that's needed after disasters. So we're working still in this space to provide connectivity to people that don't have it. Key challenge here is that a lot of them don't have power. If you're talking about developing nations, we have to sort of skip over that need for mains power, come up with solar-based solutions that provide connectivity. LeoSat's a genuine opportunity to do a lot of that, but at the same time, there's some real gaps there, so we have to go faster and do better. A little bit like me in this talk, sorry. Go a bit faster. So the road ahead, this is my last slide, and then we'll have some questions. We're connecting presence, intelligence, and intention. What I mean by that is that we started by connecting people, like phone calls. Then the internet came along and we started connecting machines, like a server to a desktop, passing information back and forth, but it was always human driven. The key thing that AI is bringing through here is that the network can be context aware. It means that we can be aware where you are, and to some extent we can be aware of what you want from a given scenario. Like if you are driving somewhere and we know where you're driving, then we can change the priority using the Kamara API to say, give this person a better connection because they're on a really important call, or they're onto 000, for example, and we need to make sure that they hold this call. Those sorts of things, that context awareness, creates a huge opportunity for all sorts of businesses and for individuals to really take us to that next level as far as reliability and as far as delivering on the jobs that we need to get done. So, sorry for the rushed second half of that talk. I was having too much fun in the first half. And yeah, I'm Dan, and let's open up to some questions. Thanks, Hugh.
So questions, we've got some roving mics, I think. Yeah, we've got one question in, there's another one at the back as well afterwards.
Thank you so much, Dan. I'm also Dan. I'm the Chief Executive Officer of the Space Industry Association of Australia and a Casio fan as well. Terrific speech, great overview. My main question is, how can Australia go on the front foot and really seize these opportunities? And I think your focus on public safety, mobile broadband is a critical example. The USA, Canada, New Zealand, the UK, many other countries have rolled out sophisticated integrated public safety mobile broadband networks years ago. In Australia, if we have a bushfire over a state boundary, the fireys are literally driving over the border to exchange a incompatible 1980s land radio mobile network. And of course, my interest is in redundancy and space and how we access non-terrestrial networks as well. Most other countries are moving on to figure out how they have truly redundant solutions that work anywhere, incorporating satellite networks. We're still trying to figure out how to move on from the 1980s. How do we get on the front foot? How do we capture these opportunities?
That's a really excellent and very insightful question, Dan. I think there's a huge opportunity there for us to specialise and go deep and leverage the things that make Australia a little bit unique. So the tyranny of distance that sort of results in our farmers not being connected and only 30% of our landmass having connectivity provides an opportunity for us to solve problems that we need solved every day, which makes it economically viable, but at the same time once the lights are out in a disaster in the US or in Europe, anywhere where you've got a main telco outage, it's pretty much the same situation here. So I do think there is an opportunity for the space-based solutions, for the highly resilient comms to be something that Australia could lead in. But because we are so small, we have to pick a few things and double down on those, and that would be a candidate for an area that we could sort of lead.
Hi, Dan. Thank you very much. My name's Rasika. I work for a company called GHD. We're an engineering company. My interest is in the space of climate resilience and decarbonisation. And I'm wondering, from the technologies that you presented today and talked through, what do you think has the greatest potential, and what are some of the use cases that you're excited about?
So I'm certainly no expert when it comes to decarbonisation, but in this space, there's big opportunities for quick wins, or quick-ish wins, in reducing the carbon footprint of telcos, and they are starting to look at that. So the standards where they can reduce the power used by the towers, if you add all of that up, it's substantial. Beyond that, I don't know of any clear focus within the industry for these technologies as far as conserving power. So obviously there's the IoT players where you can measure all of this, and obviously measuring is a good step towards solving problems. But I would say that right now it's reducing the power consumption of the telcos by reducing the amount that those towers use when it doesn't need to be running at full speed.
How about from a climate resilience standpoint? From a climate resilience and disaster resilience standpoint, I think that's more apt, right?
Gotcha, yeah. So with the increased natural disasters and increased climate variability, that does drive a need for more resilient connectivity. So I think that will drive innovation, and that will force Australia and other countries to explore how can we operate with more bushfires, with more floods, and all of those challenges that we're expecting to see.
You have a question? I've got one there. Come back to you for that.
Yes, Stuart Corn, I'm a technology journalist. On the subject of 5G not reaching its full potential, I remember back in the days of the run-up to 5G, there was a lot of talk of the lower latency supporting lots of edge computing applications, and the telcos are going to benefit by providing the resources to support that. What happened to that one?
As far as I know, they're still working on it. Like the latest narrative is that if they can do AI at the edge, then they could allow us to capture the benefits of that low latency and AI together. Whether that's just hype or not, don't know yet, but I haven't seen any commercial applications emerge at this point.
Thank you.
And then we have one more over here.
Thank you for your presentation. I have a background in surveying and geospatial. I'm interested in your thoughts on positioning technologies. Obviously indoor, I think, Bluetooth will probably be it. But outdoors, we have things like, obviously, CoreNet, but they only work when you have internet. So for farmers, do you think those sort of products that you're working on will solve it, or do you think maybe we'll just end up with better precise point positioning or things of that nature? Just be keen to hear what you think.
Absolutely. So we keep a really close eye on positioning. So farmers need to get down to a couple of centimetres accuracy to do farming on rails, we call it. So they basically want to have the tractor compact the soil in the same location each year, which improves their yields and gives them much better productivity. To get that, they either need to have an RTK station. So this is a tower that sends a correction signal out to their tractor, because the tractor gets a normal GPS signal. Then the RTK station sends a correction signal. The tractor says, I think I'm here. The base station knows where it is because you've put it in a fixed spot, and it says, no, you're not actually there, you're here. And they get down to that couple of centimetres. The cores network that we're talking about here allows you to do all of that straight over the internet. So rather than needing that infrastructure, and farmers are starting to do it, it's really common in the US where the cellular coverage is better. And I think that we'll see more and more of it, especially with AusCores being free or pretty close to free for most farmers for what they need. It's a huge opportunity, because LeoSat cellular is unlikely to be super fast, but it's likely to work well enough to be able to send a data stream for something like cores, I would think. So I wouldn't be building any RTK base stations if I was a ag service provider.
Great. Let's all thank Dan again, please. Just got a couple of announcements, I think. Are you going to put the first one up? Just to say the Premier's prizes for science are still open. I think they close pretty soon. I can't see the slide from here. But please, if you know anybody who's worthy, then please make sure they get nominated on time. And then secondly, our next talk will be on the 2nd of July, and it'll be given by Professor Andrew Dirac, who's CEO of the Dirac Quantum Computing Company. Very, very successful Australian quantum computing company. Recently raised, I think, $170 million. So it really is at the forefront of what we're doing in this state. So we look forward to seeing you again on the 2nd of July. Thanks, everyone, for coming.